Welcome to Algebra 2, Semester 2, Unit 10 and 7B. This is the first video of this packet, and it will be on transformations. After you finish this video, then you will need to do a section of worksheets in class and do an in-class activity on domain and range. First thing that I need you to do, if this is an old version of the packet, on the future versions, I'll make sure and get page numbers. But if not, I need you to go through and go ahead and number these. This one would be number 1. On the back side of it, would be number 2, and I'll just zoom out so that you can see which one is, whoa, zoom out. This will be page 2. This one will be page 3, and so on. This is page 4. Page 5. Page 6, page 7, and now we start into the actual transformation activity sheets. This is page 8, page 9, that's the square root function. The next one is cube root, that will be page 10 and 11. The next is exponential transformations, number 1, and that will be page 12 and page 13. And then the next one, transformation activity number 2, that will be page 14 and 15. Rational expression activity will be page 16 and 17, and then the back is blank. Okay, let's get going on these notes. Now I'll bring it back into focus, up close. Okay, here we go. Transformations. You guys all played with transformers before, or at the very least you've seen them. On transformers, you're just changing a shape. And that's what we look at in graphing. First off, I want to go through our basic graphs. When you see a equation with a square root, the shape that you should remember, and we'll get into why, is what one class of mine called a hook shape. Now, the reason that we can't go below 0 here is that you cannot have a square root of a negative number. Say it's -2. You can't have a square root that equals a negative number, because negative times a negative is a positive. So it won't break down into equal factors. So therefore, we start at 0. It can't go below that on the y. It also can't go below that on the x. So none of this area will have the square root unless it's been transformed. And then it's shifted to different places. But it always has this end point on a square root function. Now, because a cube root can have a negative, for example, cube root of -8, that means that there's 3 numbers that multiply. Well, we know that 2 times 2 is 4 times 2 is 8. So we could have a -8 by taking -2 times -2 times -2, and that would give us -8. So we can have a cube root of a negative number. So because it's a root, it has very similar to that shape. We have kind of the hook shape going this way, but then We also have the hook shape coming under this way because we can have negatives. Just a review from Algebra 1. This is an exponential function. Because the b value is greater than 1, it's growth. That's called the growth factor. Okay? And when we have a growth factor or a growth function, what happens is that each successive number gets that many times bigger. So let's say it was 2 to the x. That would mean each number would get twice as big. So if x is 0, 2 to the 0th power is equal to 1. 2 to the first is 2. 2 to the second is 4. So we can see how that's the one that goes up like that. Oh, I am so sorry. Just made a mistake on this. This should be the graph for this one, because that one says greater than 1. This one says less than 1. This one is the growth. I'm sorry, I was tired and not looking right. So that should be growth because it's greater than 1. This one is saying less than 1. So sorry, guys. And so it should be a decay. Hope you're using pencil. You always should in math. So let's go over and move this graph over to this. It's going up. Remember that from Algebra 1. And now we'll just erase this one real fast. Remember on the decay function, it actually is less than 1, so it goes down by factors. If we have 1/2 for this, and this one would be the 2x, if we have 1/2, it means it's cutting it in half. Let's come back up here. 1/2 to the 0th power, any number to the 0th is 1. And then 1/2 to the first power is 1/2. And that gets us the start of our decay function. Okay? So those are the basics of what you've seen in Algebra 1. We have a square root is always a hook. Cube root, remember, is your stretched out S. Decay is that L shape going down as you go to the right. A growth, because it's greater than 1 in this number here, is going up to the right. It's like a backwards L. It goes up as it goes to the right. Now these last ones probably will be fairly new to you. You should have seen them in Algebra 2-1. But in case you're taking 2-1 and 2-2 at the same time, I'll just run through them quickly. 1 over x is a hyperbola, and it comes out in this funky shape here where we have what one class termed as angel wings, or just wings. It goes this way in that area, because thinking about it as you do positives, 1 over 1 would be 1. I guess I graphed it a little bit high. 1 over 2 would be 1/2, so it's coming ever so close to this and ever so close to that one. Likewise, in the negatives, you can have negatives, and so you get the wing pattern that they talk about. The one thing that you can't have is x being equal to 0. You can't have 0 on the bottom of a fraction. So this is an asymptote here. This x-axis ends up being an asymptote. We will talk about how you can find the y-asymptote, or the x-asymptote, actually going that way. Anyway, where the graph doesn't touch on the vertical is also that y-axis, and we'll explain that later when we get into those. An even polynomial here, or an even function, you've graphed it in Algebra 1 with the squared, and remember that's simply going up like this. It's the parabola going up on each side. But I do want you to know, as we increase that in value, and maybe we go x to the 4th, it still stays in the same basic shape. You might get more of a square bottom to it, coming up like this, but they do that basic shape, a U shape. The odd, hopefully you remember from previous graphing, when it's an odd shape, let's say it's x to the third, it's very much like this cube root, but instead of just barely coming up, remember it's being cubed, so it goes up much more drastically. It curves this way. And we can have negative cubes, so it goes down that way. This one is just a linear function. It has nothing around that x, and I wanted to remind you that we have a linear function when there's no variation to that x at all. It's just y equals x. That's a linear function. Now, talking about domain and range. We will do activities in class. Domain is your x values on these graphs. Going left to right for the x value or the domain, do you see how there's no graph down in here? First time we have a graph is right here at 0. Then it can go on up here forever and ever, it says. So if I were to pretend these were a window frame, and let's say that it's made out of glass, this one I could scoot right up to here, and that line's never going to go through it, is it? It starts right here at the edge of the glass. And that's at 0. But if this arrow is, let's say, a bullet or an actual arrow flying through the air, if I put the glass down here, that pane of glass is going to get shattered when the arrow continues out and goes through it. So we say that the domain on this is limited down here. It starts at 0, but then it can go to infinity there. So the domain are the restrictions of x. Restrictions. And we just discussed that these restrictions are left to right. Are left to right when we're talking about domain. So restrictions, left, right, or the x axis. You're wanting to look at where the numbers would fall there. When we write that, let's just go ahead and write it well, we'll write it in some of the graphs here in a minute, and I'll show you the notations at that time. And then we'll study them in class with a little activity. So now the range, obviously, are the restrictions going up and down. And here, as we saw, y cannot begin below 0. So y is also restricted from 0 up, because this gradually goes up into the air out there. So if we brought in the pane of glass, it wouldn't break down here because it's got a starting point. But this pane of glass would get broken because that arrow's flying forever up that way. So restrictions, up, down, y-axis. Okay, definitely need to study and work on the activity in class a little bit on that one. Okay, we will come back and do the domain and range notations here in a bit. So skip page 3 right now. And skip page 4. I think that we'll do actually page 3 and 4 in class. Ask me if you finish ahead of other people. Now we're going to go to page 8. This is the square root transformation activity. Here is our parent function. That's what we're plugging our x value into. So I want you to take that x value, plug it in there. What's the square root of -4? Can you get two numbers multiplied by each other to equal the negative. -2 times -2 would be a +4. +2 times +2 is +4. So this becomes undefined. Square root -2. Again, can we get anything to equal a negative number? No, so it's undefined. -1 is undefined. 0, however, we can do, because the square root of 0, what multiplies by itself to equal 0? 0. Square root of 1, 1 times 1 is 1. Square root of 4, what two numbers multiply to equal 4? Multiply them by themselves to equal 4, it would be 2. And I purposely skipped 2. If I grabbed a calculator, calculate it out, it's about 1.4. Okay, so now we graph this. Nothing can happen up there. We have the point 0, 0, 1, 1, 2, 1.4, and 4, 2. So we come over to 0, 0, 1, 1, 2, 1.4, and 4, 2. That should look just like the little graph for the square root that you did on page 2. We talked about this in class. It's kind of a hook shape. The domain and range. Again, what we just discussed. The domain is limited. And just for right now, you can just say, well, x is greater than 0. It does equal 0, so we'll go ahead and put that. We're going to talk about notations in class, so make sure that you at least can see that this x-axis has no graphing up until you hit 0. The range, which is y, would be greater than or equal to 0, too, because there's no graphing down in here. It starts at 0. So that's our range. Now, we'll talk about notations in class. Got a handout on that. Why is this called the parent function? I need you to answer that. And the way that you can answer it is look at what's different between this function, that's your parent function, and all these others. What is it these others have that that one does not have? Or in some ways, I like to think of what has this one passed on to the others. Okay? So now we're going to look at what happens when we put a negative out front. If you have a negative, what you had before was just square root. So from up above, you did just the square root and got these answers. Well, if you have a negative out in front of that, that's like taking a -1 times each of those answers. You could actually do that, or you can plug these in for the x and calculate out. So let me show you that way. You'd go negative radical -4. We already discussed you can't have a negative square root, can you? So we see those would all be an undefined. Now if we go negative radical 0, well, the square root of 0 is 0. Negative, we don't put with 0. 0 has no positive or negative value. Square root of 1, square root of 1 is 1, but then we have the negative out in front. So the square root of 1 is 1 times a negative is a -1. And then you can go ahead and fill in the rest. -1.4 and -2. Now we need to take those points and plot them. We have 0, 0. 1, negative 1. That means you count over 1 on the x and down to 1. 2, negative 1.4. So 2, negative 1.4. 4, negative 2. So we go over to 4 and down to negative 2. If we connect those, what do we see? Comparing those two graphs. What's happened from our parent graph to this one? What's happened to our equation? We went from a square root to a negative square root. What is going on there? We call that reflection because it's like a mirror. If I held that up to a mirror, it would show this way. So being a reflection, now right here you would type or print reflection over the x-axis. You need to write that down in your notes. Pause the video and write it. Okay, now we go on to the next page. We're going to do another reflection here. We need to get our cube root graph. If you need to go back to page 2 to find your cube root, you can. Just a reminder, it looks like this from page 2. This time we need to plug in our numbers. So the cube root of negative 27, negative 3. Because negative 3 times negative 3 times negative 3 is negative 27. So the cube root of 27 would be positive 3. Cube root of negative 8, negative 2. Cube root of positive 8, positive 2. Cube root of negative 1, negative 1. Cube root of positive 1, positive 1. Cube root of 0, 0. So when you graph that, you have negative 3, negative 27. You obviously can't plot that out there. So now we go negative 8 on the x-axis, go down to negative 2. Negative 1 is negative 1, 0 is 0, 1 is 1, 8 is 2. And then 27 is 3, you can't get that one on the graph. That one should look similar to your square root graph, but then the negative comes in and we don't have that on a square root. Over here, what shape? Most of you call that an S shape. The domain and range, well, we can't bring any kind of restriction in here without that arrow going through the glass, can we? Even from up above, it is gradually going out as we move forward, so it would actually come up and break that glass somewhere out there. So the domain, for right now, you can just mark X. How do we want to do this? We'll just put X as all real numbers. And I'm going to show you the notations in class. So X equals real numbers, and range Y equals real numbers. Okay, I still want you to answer this. Why is that a parent function? Down here on reflection, well, let's take a look again. On the last page, what happened to the parent function and the reflection function? And what happened to your numbers? See how these were positive, now they go to negative, and when you graphed it, it reflected over that x-axis. That negative causes that transformation. So now I need you to graph this, pause the video, graph it with this reflected, and then you need to reflect these to be the opposite of what they are up here. Okay. Go ahead and pause the video. And you would again write reflection down here. Okay. Going to the next page, page 12, we have a growth function. From the last growth function that we did on page 2, try to bring this back in here some, we saw that this was an L shape that went up into the air. So it goes up going that way because each number is doubling. So let's just start at 0. 2 to the 0th power is 1. Anything to the 0th power is 1. And I start at 0 because it's a little bit easier to remember. And then 2 to the 1st power is 2. 2 to the 2nd power, that's 2 times 2 is 4. 2 to the 3rd power is 2 times 2 times 2. So we go 2 times 2 is 4 times 2 is 8. Now, do you notice how each of these are growing by the previous one? 4 times 2 is 8. 2 times 2 is 4. 1 times 2 is 2. So you could go backwards and cut them in half. That would be a half, a fourth, and an eighth. Or you can actually say 2 to the negative 3rd. Remember, you have to take the reciprocal to get that. So now when we plug those in, we go negative 3 up an eighth, just barely off the line. Negative 2 up a quarter. Negative 1 up a half. 0, 1. 1, 2. 2, 4. And 3, 8. You get your L shape. We describe that as an L shape. And the domain and range, well, if we put our arrows in here, the domain has no restrictions, does it, left to right? So domain would be all real numbers. Because anywhere that we're trying to bring in a window pane left or right, that arrow is going to break it because it's eventually going out there. On the range, do you notice on this graph that the range has to be above this line? That line will never even touch the 0. So y is greater than, and it can't be equal because it won't touch 0. Y is greater than 0. Okay? So now you should be able to do a reflection. Look back at the pattern. Remember, math is always a pattern. So look back at this pattern that occurred with the graphs, with the numbers, when you reflected. Again, we know there's a reflection because of the negative out front. So look back at the pattern from parent graph to reflection and get that in there. So now you're going to do it on this one. Look back at the parent graph, now reflect it, and reflect these numbers, just like you have on the other pages. Pause the video. When you come back, we'll be on page 14. Okay, welcome to page 14, the transformation of a decay function. I know it's decay because that value there is 1/2. So let me bring you in close again so that you can see what we're doing. Okay, so we are going to plug in these variables in for the x value up there. So 1/2 raised to the third, negative third, I'm sorry, to the negative third, in order to satisfy that negative exponent and make it usable, we flip this 1/2. So it becomes 2/1 to the positive third. 2/1 to the positive third is 2 times 2 times 2 times 2. sorry, I turned off an alarm. 2 times 2 times 2, 2 times 2 is 4, times 2 is 8. So that would be 8. 1/2 to the negative half, again you'd reflect it, and that would become 2 over 1 squared. 2 times 2 is 4. And the 1 times 1 on bottom is 1, so it's 4 over 1, which is 4. Negative 1 to the negative third would be 1. 0. 1/2 to the, I'm sorry, I shouldn't have said negative 1 to the 1. It's actually 1/2 to the negative first, which should flip it, and it would just become 2. Wow, I messed that up big time. Sorry, guys. Okay, so in other words, it was 1/2 to the negative 1, and we flip that over, it becomes 2 to the first. Now, any number to the 0th power is equal to 1. 1/2 to the first power is simply 1/2. 1/2 to the second power really means 1/2 times 1/2. 1 times 1 is 1. 2 times 2 is 4. 1/2 to the third would just multiply another 1/2 there, which would become 1/8. So as you graph this parent function, we go to negative 3 up to 8. Negative 2 up to 4. Negative 1 up to 2. 0 up to 1. 1 to 1/2. 2 to 1/4. 3 to 1/8. We see where that L shape now goes this direction because that's a decay function. Everything's cutting in half over time or as it goes. The shape we still say is an L shape. The domain, if we look left to right, this thing can go forever and ever out each way. So the domain is, X is all real numbers. The range is our Y values, and notice there's no graphing down here below that 0 again, just like the last one. So the range, Y has to be greater than 0. It can't be equal. This line's never going to touch that 0 line. Okay, look back at pages 8 with the square root function. Let me expand this out again. Go back to page 8. You did a reflection of this. Look at what it did to the graph. Look at what it did to your values when you reflected. You're looking for a pattern here. In the cube, what did it do to the graph to reflect it? What did it do to the numbers? Exponential transformation you did on your own. So hopefully that one's right. Check with other classmates, see if they got it. Because when you turn this in before the test, it needs to be correct. Now you're going to reflect this one. The way you know it's a reflection is because it's got a negative in front. Okay? The very last page that you're going to do for me in this is a rational expression. Rational expressions are pretty wild. We know that we can't have, let me get this a little bit closer. We know that we can't have 0 on the bottom because that's an undefined fraction. So when we plug 0 in for x, that's undefined. So it means it can't happen right there. But if we plug in negative 1, 1 over negative 1 is the same thing as negative 1, right? That's negative 1. If we plug in negative 2 for x, we would have 1 over negative 2. That's the same thing as negative 1/2. Plug in negative 4, it would become negative 1/4. If we plug in positive 1, it would become 1. Plug in positive 2, it becomes 1/2. Plug in positive 4, it becomes 1/4. So let's graph that much. We know we can't have it on 0. It's undefined there. So we could go ahead and put an asymptote there when x is 0. It's undefined. And now we plot our points. At -1, it's -1. At -2, it's 1/2. At -4, it's -1/4. So we've got a curve coming like this. My curiosity is what happens at 1/2? If we plug in 1/2, it becomes a complex fraction. So we have 1/1/2. That's the same thing as 1 divided by 1/2. You remember right from Algebra 1, you'd flip that second one, you'd multiply, so 1 times 2 is 2. So at -1/2, our value is 2. It's actually curving up real fast that way. Interesting, but this seems to have a mirror image graphed right on the same graph. If you look here, at 1, it's 1. At 2, it's 1/2. At 4, it's 1/4. So we've got the same curve going right up here. Okay? That is a hyperbola. Again, it's got an asymptote this way, but it also has an asymptote this way. Asymptotes, remember, are those lines of which the graph won't touch. They won't go onto those lines. So that kind of changes our domain and range. Our domain and range we can list as going on and on forever that way and on forever that way, but we've got a dead spot right in the middle, or a no zone. So when you get to domain, it's kind of funky on this one. You go, domain is x cannot equal 0. Range, y cannot equal 0. What shape would you describe each graph as? This is the one that we called angel wings, or wings. I don't know why they said angel wings. Maybe we were feeling really something with angels that day. So anyway, I don't care if you have an angel or just wings. So now, look at the pattern for reflections. Go back to these other graphs on previous pages and look at the pattern that's formed mathematically. We go from a parent function to a reflection on the graph. Look at how it occurs. Look in the numbers how it's occurring. Do the same here and here. And do the same again here and here, here and here, and here and here. Check with classmates when you get to class. That is the end of reflections on transformations. And now our next video will have transformations with shapes. Thank you very much.